Hello everyone, welcome to my channel. Today we are going to see how to solve maximum sum array problem. So let's start. So first we will see the problem statement. Here the problem statement is find the contiguous subarray within an array which has the largest sum. So within an array means it should contain at least one number. So for example, the given array is -2, 1, -3, 4, -1, 2, 3, -7 and 4. So this is the array which have 9 elements and we need to find the maximum subarray, means the continuous subarray with the maximum sum. So here for this example, we have the contiguous subarray 4, -1, 2, 3. The sum of which is 8. So this is the output for this given array. So here we need to find a part or a segment of this array which should be contiguous and it must have a larger sum. So let's think how we can solve this problem. So here we can have at most 3 scenarios for this problem. The first scenario is array may consist of only positive numbers. The second scenario is array may consist of only negative numbers. The third scenario is array may consist of both positive and negative numbers. So these are the 3 scenarios which we need to think about during solving this problem. So let's see. So first we will consider this scenario where we will have all positive numbers in an array. As all the elements in this array is positive, so we can consider the entire array as a subarray and the output for this is 172, which is a simple summation of all the elements. Okay. In the next scenario where we have only negative numbers in an array. So in these 3 elements, -10 is the number with the highest value. So we will consider only -10 as the output because it will give the maximum value. So in next scenario, the array will have both positive and negative numbers. So here we have a Kadanes algorithm which we can apply to solve this problem. So here as you can see, we have a array with 9 elements which have both negative and positive elements. So as in the previous slide, I have considered the same example. You can see the output array is -4, -1, 2 and 3. So this part is basically the output of this given array. So here we will apply Kadanes algorithm to solve this problem. So let's see what Kadanes algorithm says. So this is the pseudocode for Kadanes algorithm. So let me first describe what Kadanes algorithm says. So Kadanes algorithm is relevant only to those arrays which have both positive and negative numbers. So in that case, our array can have at most 0 as the answer, because as we have both positive and negative numbers, the final output should not be negative. So here we can initialize 2 variables, temp sum and the final sum. So here before starting with the algorithm, we will initialize 2 variables, one for the temporary sum and one for the final sum. So the concept of Kadanes algorithm is to traverse each element of an array and consider only those segments which have the maximum sum. So here we will look through each element of array. We will add each element to the temporary sum. As soon as the temporary sum becomes negative, we will set the temporary sum to 0, and if the temporary sum is greater than final sum at any point, we will set the final sum to temporary sum. So this final sum will become our output at the end of this algorithm. Okay, and we will simply return the final sum as output. Okay, so this is about Kadanes algorithm. Now we will walk through on an example with the given array. So this is the same array. We will consider this as an example and we will try to dry run this Kadanes algorithm through this array. So initially we will initialize temp sum equal to 0 and final sum equal to 0. For I equal to 0, the value is -2. So we will add this value to the temp sum and then we will check if temp sum is less than 0. As the -2 is less than 0, so the temp sum will reset to 0. And after this step, we will see temp sum is not greater than final sum, so final sum will remain as 0. Okay. So in the next iteration, when the I equal to 1, the value at position 1 is 1. So we will add this value to the temp sum. Now temp sum is greater than 0. So the temp sum will become 1 and we will check if temp sum is greater than the final sum, then the final sum will be equal to 1. Then in the next iteration, when I equal to 2, we have temp sum equal to 1 and final sum equal to 1. So in position 2, the value is -3. So adding -3 to the temp sum 1, it becomes -2, which is less than 0. So again the temp sum will be reset to 0. And as temp sum is not greater than final sum, so final sum will remain as 1. Okay. In the next iteration, when I equal to 3, the value is 4. So as temp sum was reset to 0 in the previous iteration, it will, after adding the value at position 3, it will become 4. And as temp sum is greater than 0, so temp sum will become 4. And as temp sum is also greater than final sum, so final sum will become 4 in this step. After this step, in the next iteration, when I equal to 4, the value at I equal to 4 is -1. So we will simply add this value to temp sum, which is 4, and it becomes 3. So as temp sum is still greater than 0, so temp sum will remain as 3, and as temp sum is not greater than final sum, so final sum will also remain at 4. In the next iteration, when I equal to 5, we have a value at I equal to 5. So in the next iteration, for I equal to 5, the value is 2. So 2 will be added to the temp sum and it will become 5, and temp sum is greater than 0, so temp sum will become 5. Here the temp sum is greater than final sum, so the final sum will become 5. Again, in the next iteration, when I equal to 6, we have temp sum as 5 and final sum as 5. So the value at position 6 is 3. So we will add 3 to the temp sum and it becomes 8. As the temp sum is greater than 0, so the temp sum will remain to be 8. And as the temp sum is greater than final sum, the final sum will become 8. So in the next iteration, for I equal to 7, the value is -7, and when we add -7 to temp sum, it becomes 1, which is greater than 0. So the temp sum will remain as 1, and we will compare temp sum with final sum. As temp sum is not greater than final sum, so final sum will remain as 8. In the next step, when I equal to 8, the value is 4. We add the value to temp sum and it becomes 5, which is again greater than 0. So the temp sum here is 5. So again here, temp sum is not greater than final sum. So the final sum is 8. As we reach to the end of the array, we will return final sum as a result. So as you can see, using Kadane's algorithm, we just need to traverse each element of an array to find the maximum sum of a subarray. So here, the time complexity is order of n. So now we will jump to the code and see how we can code this problem. So this is the code I have written in order to solve this maximum sum subarray problem. So here I'm using scanner for taking the input. So here I have declared one variable number of elements. So user will need to provide the number of elements in the array. Then we will create an array of that size, and then we will simply take input from the user and we will store it in the input array. So after initializing the input array, we will check if all the elements in an array is negative. So we will simply iterate through each of the element and we will see if any of the value is greater than 0, that means the array contains positive values. So we will simply do if all negative we get true as all negative, that means the array has all negative numbers, then we can simply get the negative result, which is we will simply iterate through each element and we will find the negative number which has the highest value and we will return it as a result. So if in an array we both have positive and negative values, then obviously we will get one positive sum as a result. So here, as you can see, this is the Kadane's algorithm I have written here. So here, as I mentioned, we will initialize two variables, the temp sum and the final sum. Here, we will iterate through each element and we will keep adding those elements to the temp sum. As soon as the temp sum becomes negative, we will reset the temp sum to 0. And after each element, we need to check if the temp sum is greater than final sum. If we have temp sum which is greater than final sum, then we will assign that value to the final sum and which will become our final sum. In this way, as soon as we complete iterating through each element, finally we will get one value which will become the final sum. So we will return this value as a result. Now we will run this program. I have few test cases here, say for few test cases for all the three scenarios. So let's say I have three positive numbers, 12, 7 and 153. Here you will get output 172. If we consider this example, say we have 9 elements. Let me copy this test case. So here you get 8 as output. So let me run this example also with 3 elements. So in this example, all we have are negative numbers. So -10, as it has the highest value, is the output. So that's all about this code. So I will add the GitHub link into the description. Please check it out. So thank you for watching this video. If you have any questions, please write your questions into the comment section. And if you like the video, please hit that like button and also subscribe to my channel. And please share this video with your friends. Thank you for watching.